Hi folks, and welcome back to Physics with Captain Rod. I'm making this video to introduce you to the idea of centripetal force. And I've already defined this in my previous video, but a centripetal force is any force that causes a centripetal acceleration. So maybe a little overview of centripetal acceleration. Centripetal acceleration, magnitude-wise, is v squared over r, where the v is the speed of the object, the r is the radius of curvature. It is always directed towards the center of curvature. And it's an acceleration that is, not sure what word to put here, linked to or caused by the changes in velocity direction. So in this picture, what we're looking at, imagine a tennis ball attached to a string, and a person just kind of, whirling it in a horizontal circle in a pretty fast manner. Now, one thing to point out, you'll notice that this is pretty well a level circle as opposed to something like this. And what that means is the person is moving it fast enough that the tension in this string is quite a bit larger than the gravitational force. So the gravitational force is really small, and we're not going to consider it in this problem. And if we did a snapshot of this ball at that location and draw a free body diagram of it, the only reasonable force acting on that ball is the tension in the string, and that tension is pulling in this direction. And that tension is causing the ball to change direction. And the acceleration associated with that, again, is a centripetal acceleration. So this tension would be referred to as a centripetal force. Now, when I ask students, or anybody for that matter, to draw a complete free body diagram of that ball, a lot of people want to add another force, some sort of outward force like this. And I ask them, what is that? And they always say something like, well, that's the centrifugal force. I'll just put F here for that. And I ask people, like, well, why are you putting that there? And the number one response I get is so that the forces balance, or so that the net force is zero. And what you have to realize is that the forces in this picture are not balanced. They shouldn't be. That ball is, in fact, accelerating towards the center of curvature. This force that we call a centrifugal force doesn't actually exist. It's called a fictitious force, and I'll just make up another video about that. But long story short, it's basically kind of like a figment of your imagination. It feels real. I know that people believe they've experienced centrifugal forces when they are, say, in a car and going around a curve or something like that, and you feel that outward force. But that's not actually an outward force. What you're feeling is the car kind of like accelerating out from underneath you and then applying forces to you that actually are accelerating you inward. It's just a trick of the mind, I guess I'll say. There is no outward force in that example of the car, a person sitting in the car and going around a curve, nor is there an outward force acting on this ball. The only force acting on that ball is this one right here. And another thing I always remind people of is that forces can be classified as either field or contact. And when you look at this ball, throwing out air drag, there is only one contact with it, the string. Right? There's nothing pushing that ball to the right or pulling it to the right in any way, shape, or form. So, again, the idea of a centripetal force, it's any force that changes the direction of your velocity vector, right? And makes an object move in a circular path. So it's typically inward forces that change the direction of your velocity vector. And centripetal forces, when we apply Newton's second law, it would typically look something like this. Sum of all forces equals mass times acceleration. In this example right here, the acceleration is to the left, So we would write left positive typically if you follow my standard rule of thumbs. Remember Captain Rod's rules of thumb, identify the acceleration direction and call that positive. So when we look at this free body, there is only one force. That's it. And then the acceleration, taking note of or recognizing that it's a centripetal acceleration, is equal to v squared over r, where the r would be the radius of curvature that the ball is, the path that the ball is taking. So this video is just meant to be an introductory video to centripetal force. I hope that that has done so for you. Have a great day.